Okay, we're going to use part one of the fundamental theorem of calculus to find the derivative of the function. Now, I'm going to do an explanation which is longer than what you would say do if you're doing the problem on a test. I'm going to write this as y equals the integral from 1 to u. Oh man, what happened there? Okay, 1 to u ln t dt. So what I'm doing is I'm replacing this e to the x up here by u. And what I am trying to emphasize that this is a composition of functions. So when I take the derivative, we use the chain rule. It's a composition of y equals integral from 1 to u ln t dt and the function u equals e to the x. So when I find the derivative, I take the derivative of this integral function 1 to u. Now, how do we do that? The derivative, see, the thing is what I'm going to fill the side of the paper. I don't think you necessarily have to, but if I take the derivative, dy du, I have d du of this integral 1 to u ln t dt. What happens is that the derivative and the integral cancel each other out. That is the fundamental theorem of calculus part 1. And so our answer is I replace u inside of I replace t by the u and I get ln u. So this becomes ln u. All right, that's how but this part I just wrote on the right-hand side might confuse the whole thing. So the shorter thing is to think about this is not to write all that junk. Just look at this e to the x. It's going to go where the t is. So I replace, that's u. I replace that there. But with the chain rule, I have to follow up with the derivative of the e to the x. Right here, I'll multiply by the derivative of the inside. And what's that? That's e to the x. Looks pretty good, but we can even do better in terms of simplifying. Ln and e to the x cancel out. They're inverse functions, and so we get x. Does anybody have a question about that? Anybody want to speak up for questions? So let me do the number 15 and see if I can not write as much junk on the side of the paper. But on the side of the paper, what I have is y equals the function integral 1 to u ln t dt. I take the derivative with respect to u, and I get the u replaces t, and I get ln u. And then I didn't show this, but then you multiply by du dx, which is e to the x. And so then the idea is the chain rules, you multiply ln u and e to the x together, and there you go. Okay, let me just somehow, what the heck? Let me just move this over here and try to make this. Let me just put a little box around the side stuff. Oh, brother, I'm taking too much time on that. Okay, so just put a little box on that side stuff. Okay, let's not do all that side stuff this time. Y prime is what? I use the fundamental theorem of calculus part 1 where the derivative kills the integral. It kills the integral, and all I do is I just go ahead and write down the function. But when I write down the function, I'm going to leave a blank space where t is. See, and whatever is up here, if it's x, I'll put x in for t. If it's s, I'll put s in for t. In this particular case, what's up there is 3x plus 2. Whatever's up there, I put in there, okay? But then what do? The chain rule is multiply by the derivative d dx of 3x plus 2. Of course, that's an easy derivative, which is 3. And is that Is there any extra? Maybe you could just write it just a little differently. 3 times 3x plus 2. Don't bother, and actually don't even do this, of multiplying out this 3x plus 2 to the third power. I don't think that would look good to expand that. I feel like I have a connection with the author in mind meld, and I can tell that I don't think he would do that for the solution guide. Okay, so we'll zoom out here, and the second one I showed less work, but when you use the fundamental theorem of calculus 1, you take the derivative kills the integral, and whatever is on the top, 3x plus 2, in this case, you put that in for t. If it's just x, put an x in, and the derivative of x is 1. But here it's 3x plus 2, you put in, and then you multiply by the derivative of 3x plus 2, which is 3. Okay, so we'll finish up that, done with that video.